Welcome back, dear students. Let's continue with the chapter on area of a trapezium and a polygon. Okay, so all of you know that we are doing exercise 20b, right? So from 20b, let me take question number 12 for you. So here question says each side of a rectangle is doubled. Okay, so basically we have first a rectangle given to us. Okay, so for example, let's consider this particular rectangle. Okay, so we have this rectangle. So let me say that the length of the rectangle, okay, so let me say that the length of the rectangle is x, okay, and let me call the width of the breadth of the rectangle to be y. Okay, so each side is doubled. So we have two cases. One is initial case, that is the starting case. So we have initial case and we have another is final case. Okay, so we have final case. Now initially at the starting your length is, okay, so let your length be equals to x, okay, and let your breadth, that is b, be equals to y. Okay, now question is saying that later on your length is becoming double, that is your length is becoming 2x. Okay, so your length is becoming 2x and your breadth is also getting doubled, right? Because each side is getting doubled, right? So length is also getting doubled, your breadth is also getting doubled, so that's why your breadth becomes 2y. Now what we need to do is you need to find the ratio between the perimeter of the original and the resulting rectangle. And number 2, you need to find the ratio between the areas of the original rectangle and the resulting rectangle. Okay, so for both, what will I do is I will find area and perimeter. Okay, so therefore it's perimeter. So perimeter is going to be, now all of you know the formula for perimeter is 2 into L plus B, right? Yes, so this is your perimeter formula. So let's find what is the perimeter. So 2 into L, L is x and B is y. Okay, so this is your perimeter. Similarly, let's find its area also. Okay, so area is L into B, you know that. So length is x and breadth is y. So x into y is xy. So we got both perimeter and area of the first rectangle. Okay, now let's find what is the perimeter and area of the final rectangle. Okay, so let me erase this part. Let me erase this part. Let me write it here. All right, so we have, so next is final. Okay, so you will write this just below this. Okay, so we have, in the final case, your length will be double, that is 2x, and your breadth is 2y, right? So therefore your perimeter, so again perimeter becomes, so you have formula is 2 into L plus B, right? So we have, this is 2 into L. L is, what is its length? Length is 2x, right? Plus what is breadth? Breadth is 2y. So is there anything common here? I see that 2 is common. So bring that 2 outside. That 2 and this 2 gets multiplied. So 2 into 2 is 4. So you are left with now x plus y here. So this is your perimeter of the resulting rectangle. And similarly, let's find the area. So area will be, okay, so area will be length into breadth. All of you know length is how much? Length is 2x, right? Into what is breadth? Breadth is 2y. So how much is this? So 2 2s are 4, x into y is xy. So this is your breadth. Okay, now let's find the answers, the final answers. Okay, so question is asking you to find the ratio, right? So let's find the ratio. So let me remove this this thing because I don't need this as such. Okay, so we have to find now the ratio, right? So therefore ratio between perimeters. So number 1 is perimeter, right? So perimeters of original rectangle and resulting rectangle. Original and resulting rectangle. Okay, so we have this will be equal to, so first what is the perimeter of original rectangle? We have to write that. Okay, so original rectangle is 2 into x plus y. So ratio means you have to write is to. Now what is the resulting rectangle? What is the perimeter? Perimeter is this much. So we have 4 into x plus y. So here x plus y and x plus y gets cancelled. Similarly, we have 2 ones are 2, 2 2s are 4, right? So that means your answer turns out to be 1:2. So your first answer is done. Now next we need to find ratio between the areas, right? So therefore ratio between the areas of original and resulting rectangle. Okay, so let's see what will be the ratio of the areas. So what is the area of original rectangle? It is xy. So we have xy is 2. Now the resulting rectangle has area to be 4xy, right? So 4xy is there. So y gets cancelled, x and x also gets cancelled. So we have only 1 left here is 2. We have 4, right? So this will be your answer. Okay, so this is your first answer and this will be your second answer. Okay, so you may pause the video and note down your solution. Fine. So let's begin with another question now. So just observe this question very carefully. Okay, so let me keep one margin out here so that I'll be able to solve two sums in different margins. Okay, so we have here, if you observe here, then the question is saying, okay, first and foremost, in both the cases, in each of the following cases, ABCD is a square and PQRS is a rectangle. So see here carefully, PQRS is a rectangle. Here also you have PQRS. So this is also a rectangle. Okay. Now, in each case, find the area of the shaded portion. So you need to find area of the shaded portion. Okay. Now, how you find area of a shaded portion? Okay. So I am just giving you a hint here. So area. Okay. So we have to find area, right? So we have area of the shaded portion. So let me do the first question. Okay. Now if you see here, we have to find the difference. Okay, let me tell you how do we find shaded portion, area of shaded portion. Now we find area of shaded portion by just finding the difference. Now we have to find difference between what? Now we have to find difference between the figures. Okay, so for example, you have, what is the bigger figure here? Here we have bigger figure is a rectangle, right? So here we will find first, what is the area of rectangle? That is bigger figure. Okay, rectangle. Okay, and we have smaller figure is a square, right? Question says ABCD is a square. So smaller figure is a square. So we'll find its area also. Okay, so we'll find area of square. Okay, see here, I've written first area of rectangle because area of rectangle seems to be bigger, and later on I have written area of square. Okay, because it is smaller. So what we'll do is we will subtract the smaller area from the bigger area in order to find the area of shaded portion. Okay, we do the same thing here as well. So here we have area of shaded portion, area of shaded portion. Okay, so all of you see that in this figure, which one is a bigger figure? Obviously square is bigger, so that's why here I need to write area of square in front. Okay, and I'll write area of rectangle because rectangle is smaller, so I'll write rectangle later on. Okay, right, so let's see what will be the answer for this? So here, if you see length, area of rectangle, what is formula for area of rectangle? It is length into breadth, right? And we have area of square is given by a square, that is side square. Now what is length for the rectangle? Length is given to be 3.2 and it is in meter, remember. So it is 3.2, length is 3.2 into breadth, breadth is given to be 1.8 minus a square. So each side of the square is given to be 1.4, so it is 1.4 square. Okay, so let's quickly evaluate this. So we have 3.2 into 1.8. So quickly multiply, you see that it will be exactly 5.76. Okay, so it will be 5.76 minus, so this will be 1.96. Okay, so find the difference now. So when you find the difference, your answer turns out to be just 3.8. okay, so it will be your 3.8. so since you are finding area, your unit is going to be meter square. So this will be my answer for the first question. Okay, so for the second one, we will do the same thing. So we have area of square is a square minus area of rectangle is length into breadth. So a, each side is given to be 6 meter here, so it becomes 6 square minus length, length of the rectangle is given to be 4.8 into breadth is given to be 3.6, right? So 6 square is 36 minus, so we have 4.8 into 3.6. okay, so it turns out to be 17.28, 17.28. so find the difference. So when you find the difference, you get your answer to be 18.72. okay, so your difference turns out to be 18.72 and again your answer will be in meter squared. So this is your area of shaded portion. Okay, so you may pause the video and note down your solution. Let's move to next question. So question says a path of uniform width 3 meter runs around the outside of a square field of 21 of side 21 meter. Find the area of the path. So what they are trying to say here is there's a square field. Okay, so we have a square field out here. Okay, so this represents a square field. Now what happens is around this square field, there's a path. Okay, so there's a path of uniform width. So that means, can you tell me, okay, so suppose if I draw a path of uniform width here, then this outer figure will also be of which kind? This will be also a square shape, right? Are you able to understand? Okay, so what we'll do is we will draw one more square. Okay, so I have taken one more square here. So if you see here, if you observe this diagram, this white portion is your field. Okay, so this is your field. Okay, and each side of this field is given to be 21 meter. Okay, now when if you see here, when there's a path of uniform width, okay, so if you are not able to see, let me zoom it a bit for you and show you. Okay, so if you see here, now all of you know from here to here, so from here to here is 21 meter, it is given. And what about this width? How much is this width? This is given to be 3 meter. So similarly this width is going to be 3 meter. Okay, so altogether from here to here is how much? So from here to here is 21, so it is 3, this is also 3, so it's gonna be 21 plus 3 plus 3, which is equals to 27 meter, right? So that's why let me go back to my working page, original page. So that's why if you see here, Isn't this a problem like earlier problem, right, where you have to see here carefully. So this is given to be, this outer part is given to be square, that is the biggest figure is also a square whose each side is this much, okay, 27 meter. So how we do this is area of each side of, let's say, so from the given situation, the following diagram can be drawn. So the following diagram can be drawn, that is, this diagram can be drawn where the shaded portion, that is the shaded portion, where the shaded portion represents what? It represents the path, right? So represents the path. Okay, so basically question is asking you to find what? Question is asking you to find the area of this path. Basically area of the path means you have to find area of shaded region, isn't it? So therefore let's say, okay, so each side, therefore each side of the outer that is bigger, okay, so outer square, right? So because the path is in square shape, so it is, you know, it will be 21 plus 3 meter, which is 27 meter, okay, and you have the dimension of the field as well, which is 21 meter, right? So therefore you write this as area of the path is area of shaded region, right? And you know area of shaded region, we find it by using the formula area of bigger square minus area of small square. Okay, so now put the values and find your answer by yourself.